let's walk a little bit. Yalla bala. So
Now you can see I'm blushing.
I don't hear you, but as this year we start with the BOQ, and we start with the BOQ by running, meaning we didn't stop in order to make it bad. At this stage, we can do it properly, and we can do it clean and clear for everybody. And at the end of the day, this will help you in our work. So not a lot to say here, but if you go line by line, you will see that all the works are included here. And it's very important in order not to forget nothing, and in order to check each one of the items. And if you see 5.501 and 502, the first two lines are in fair soil and in hard soil. We are talking about excavations for pipe laying. And my friends, you have it a lot of times. Indefeli has it in KMZ, and Dennis has this one also, and Omri and William had the same problem in Cameroon, when all of a sudden you see that your soil is not soft soil, is stones. And the subcontractor comes to you and say, look, I suppose, or it's supposed to be soft soil and it's stones, hard rock, it's another price. And everybody's surprised, and we stop the work and we start dealing with it, so on and so forth. But the right way to do it, as Shai said, and as Omri said, when we sign the MOU with the population and the contractor, you, water engineers, you need to walk all the 4, 5, 3, 2 kilometers by foot. You need to know what your site is. And in the moment you do the visit in the site, you see if the soil is fair, and if not, if it's stony. And if it's stony and you have any doubt, so make some diggings. Open, I don't know, each 500 meters, some holes of 1 meter by 1 meter by 1 meter, and check it. So no surprises will be, because you know that for the 3 kilometers of the project, 2 are in fair soils and 1 kilometer is in hard rock. So you know beforehand. And before you sign with the contractor, you already know. Again, people, you need to walk by foot, okay? Thereafter, we see here, and it's also very, very nice, this BOQ, because it's line by line as the work should be done. The backfill is into the two first layers. The 5.4 is supply installation of the warning plastic strip. You remember that after half a meter, we put a plastic strip in order to people that are digging, not our people, other people that are digging electrical cable or some drainage, no matter what, they know that we have a pipe here. They found the plastic strip and say, oh, I need to be careful here because there is another pipe here. That's why we installed this pipe. And in 505, we have the other 2 layers of backfilling, and it's very well described. So all those lines will help you and us and the contractor in order to do the work properly. Thereafter, we have all the diameters of pipes, and not in all the projects we have 63 mm pipes, but it's important to be here, not to forget nothing. We have everything here. If we don't have any 63 mm, so the quantity should be 0, never mind. And the other stand is for 10 atmosphere, that is 100 meters. And in most of our projects, we don't get there. Only in hilly areas in South Africa, in KZ, we have like 130, 150 meters pressure. But usually we have much less than PN10. We can afford the PN6, but the difference between PN10 and PN6 is not only the pressure they can stand for, it's also the wall, the thickness of the pipe. And PN10 is stiffer than PN6. And that's why we are asking for the PN10. We could ask the PN16. It's very hard to work with. It's very, the cost is much higher, so there is no need. PN4, don't do that. PN4 is a very, very weak pipe. So that's why we choose the PN10. And in several cases, if we are tight our offer in our BOQ with the contractor and the pressures allows fit us, we can do the PN6. But we should ask the PN10. Plumbing walls for water distribution points. Nothing much to say here. We see it's very well detailed. We cannot forget nothing because everything is here, okay? Let's go further for the borrow to tower. Here you see from 519, pipeline from borrow to tower. As we said yesterday in the meeting about the EPANET, we have always like two systems. One system by pressure that is going from the borrow up to the tower, and the second one, or to the pump room, and the second one going from the tank to the distribution system. So here we refer to the first one, to the system under pressure going from the borrow up to the tank. And that's why here we, in 514 and 515, we have 90 mm and 75 mm, because in several cases, 50 mm or 63 mm, they don't do the work because the head losses are very high. So we need to install 75 and 90. That's why we add here the 90 and 75 mm, okay? And we don't go lower than 50 mm. By no means, we are not going from the borrow to the tower lower than 50 mm. That's why the range here is 50 till 90 mm, okay? Thereafter in chapter B, we have, can we go down please, Shai? In chapter B, we have from 519 up to 5 and the end of the chapter, we have all the accessories for the pump room, okay? Till 541. Till 541, we have all the accessories for the pump room. And I will tell you, maybe this detailing is too much. I will tell you a principle in BOQs. As much lines you price or the offer that the contractor will ask will be. It could be much piping works inside pump room, one price. And
I think we lost Yaakov. I don't know if we should wait a couple of minutes or we should just move on because we are on a tight schedule here. We'll probably rejoin in a few minutes.
I can see already many questions.
Yeah, okay, we can do that. Many questions I see as well. I'm just going up. Please, for all your comments about the BOQ, it's very great that you're specifying here everything you think that should be changed. but please, if we can do it more orderly via Zoom or email. I know I see that you have many comments for South Africa, so that's great. But please, let's do it in another time. Just keep your notes, it's very important.
Shaya, I'm back.
Hi, hello.
I went loose when I was talking about the internal piping works.
Yes, here about the many lines we have inside the pump room.
So I will repeat. As a matter of fact, if you have more lines, the price will be higher because the contractor needs to put some value there. So if we are 10 lines with all the details, the price will be higher than if you have only one line for the general work. Meaning, if we could add here only one line, meaning internal piping works inside pump room, and the contractor to giving us the price, and we put there as per design, finish. But because we see that it's a little bit hard in 2021, I believe that in 2022 will be much easier to get what we want. We specify each one of the accessories in order to receive exactly what we want, what we design. But I believe that at the end of 2022, maybe in 2023, you can spare all of that. You will know, we already know the normal price in all the countries for this chapter, $1,000, $1,200, $1,500. If someone is asking more than 1,500, is very high. Several times in Tanzania, they're asking a little bit less. But the normal price should be 1,200 or so. So at the end of the day, we don't need all the details here. But for the time being, we prefer to put line by line, everything here, in order the contractor not to say, I didn't know, I didn't understood, everything is written and everything is designed. So no way he can do any mistake, even so they're doing. So that's why we put a lot of detail here. Can we roll down a little bit, please? Yeah, and here we have the external pipe works, the outlet, the inlet, and the outflow pipe. As we know, we are going from the pump room to the tank in 2 inches galvanized iron pipe, and we are going down from the tank into the distribution line the same. In the middle, we have the cabinet, and it's important to still to understand, generally speaking, we want that, we like that, all the pipes that are over the ground should be galvanized, and all the pipes that are under the ground should be HDPE. So the question is, where are we doing the changing? Where are we changing from galvanized to HDPE? And what we decide to do is to do it in the cabinet, because everything is protected there. So we come down into the cabinet with galvanized, we go out from the cabinet in HDPE. So the HDPE is open to the air for 1 meter or less, no more. And from there after, we have the 200 mm sleeve PVC pipe 8 inches. The HDPE pipe is coming down from there to the distribution lines. So that's why all this chapter is here, okay? And we have painting and decoration and miscellaneous work. Let's go to miscellaneous work. We have here the lightings, and we have here the sleeve that you mentioned. This sleeve is nothing, okay? It's really nothing of it. The other sleeve, the sleeve that we have here is the sleeve if we need to cross a river or a water stream or a road or something that we'll try to avoid to do. But if we need to cross a local road, our pipe should be protected. And that's how we protect our pipe. And of course the tanks, and we add also the line 553 for this 5,000 liter tank, if needed in another tower, in a second tower, or in any case, In most of the cases, it will be zero and no price here, not applicable, but even so, it's here. Another thing that I like to show here, maybe if you can go up, please, Shai. Maybe Moti already explained it. Go please to cell I8. Please stay in I8. Yeah. You see here that what we have here is two columns, amount local, amount in US dollars. And the important thing here, as the rate is always the same, is D8, $D, $8 coming from the BOQ summary. I don't know, please tell me.
Can I help with this here?
If it was already explained or not. If
No,
not,
it wasn't explained and it probably should be.
I can do it, Sarah.
Go for it, please.
Okay, so you see here that in, let me take it out, it's bothering me, sorry. You see here that in line 8 and in column D, D8, you see the exchange rate, okay? Let's say that is 200. And it's only in one cell in all the project that you have the exchange rate. And any value in all the Excel is divided by the same cell, because you change the exchange rate once, you change for all the project. And this is very important. And this is very important that we have the two values here. Why? Because local people are working with local money. Our donors are giving us, and our budget is in dollars. So it's important to have the ratio. And not only that, at the end of the day, we can do any kind of contract with the contractors, but it's important both of the amounts to be written in the BOQ. You like to add something, Tara?
Yeah, I would say that it's just important that when we share these templates with the contractors, that they understand that they need to fill out specifically that BOQ summary sheet where you see the exchange currency and the exchange rate, which is formulated in every single tab. They should not be touching anything but the rates per each line item, okay?
Okay, let's come back, please, Shai, to where we were. A little bit lower. Okay, and the end of the day, we have here the subtotals. A, distribution network plumbing works. B, plumbing for tank, external and internal manifold, and miscellaneous works. And also, it's very important each time to check the quantities and to check the arithmetics. Not once we see errors in the arithmetics, meaning the subtotals ABC are not correct, the grand total is not taken correctly to the summary. So not only to check each price and each line, also to check the arithmetics. Can you go roll up, Shai, please, to the pipes? Yeah, we see here from 506 to 510, those pipes. And I should ask, but I know that you know, that the quantities here, we get the quantities from the EPANET. And in the meeting that we will have, I believe it's Monday, with Mori, with the exercise in the EPANET, probably Shai will show you how from the EPANET we take out the quantities and we can, from the EPANET, install the quantities here or to check them. Because maybe that the contractor say, look, I have some HAPFAL, I need to add here like 5% or so. But it's very important to check that the quantities coming out from the EPANET are coming into the BOQ. It's a lot of times we see differences in the diameters, in the longitudes, a lot of differences, and we are paying a lot of money here. So one of the outputs, one of the main outputs of the EPANET is the quantities, the list of quantities, and that list of quantities should be here one by one, maybe with a little difference because of HAPFA, but nothing more. From my point of view, I believe that the water BOQ was presented, and from my side, Sivan and Shai, I am open to questions if you like so.
Thank you, Yaakov. And we have many, and I do want us to take the time to answer as many as possible. And regardless, I do believe that we should find the time for you and the managers and the water engineers, of course, to again discuss the BOQ and get some suggestions. But for now, let's start. Thank you, Yaakov. If we can start answering. Tara, Michal, can you please help, or Shai?
Yeah, actually there was Indifile from South Africa really had some great questions discussing line by lines, but it was suggested as also with the construction that they put it together in an email so we can continue really going into details. I think that maybe we can answer these two from William real quickly though. He says in the trenching section of 5.01, what solution should be used in the case of trenches that pass through areas where 50 centimeters of water is coming out of the subsoil, especially when the area is flat?
I know that, William, you had this issue in Cameroon, and in the manual, it's written that the contractor there is a chapter, sub-chapter called dewatering. And it was very interesting because the same week, Sivan asked me, look, Yaakov, we have problems with the watering. I said, till the moment, no. So why we are talking about the watering? Look, because there could be the possibility of the watering. And 1 week later, Omri came to me and say, look, we have a problem of the same that you asked now, William. And what we do is very easy. It's not so easy, but can be done. One, we need to drainage the water. And you are asking me how? Two possibilities. Even by a pump, you install a sludge pump, a pump that is working with used water, not with clean water, that the breeze doesn't making any problem to the pump. And you are dewatering with a flexible pipe far away. This is one. Secondly, you should understand the topography of the area and to know where to drain, and they can dig some channels. And it's not so difficult to be done. Those are the solutions. I can give you more complicated solutions, but they're not practical for us. So the two very easy ways, one with the pump, and taking out from the channels the water, this is one. And secondly, open channels, drainaging the water out of our area, okay?
Okay.
But because,
I don't know if that affects it all.
But because it's written in the manual and in our contract, the contractor is complying the manual, at the end of the day, it's his responsibility, and you don't need to pay any extra money because it's written there. So you should do that, okay? We are protected.
Okay. On a similar note, maybe you answered it as part of it, but what is the solution to put in place when the rock is so hard that it's difficult or impossible to reach 1 meter?
Excellent question. We don't have one answer, as we said, one school answer or one book answer. We have a lot of alternatives. Look, we had this case in South Africa, and I had it in Ghana in other projects. And I answering not directly the question, I rather asking, answering a harder case. If you have rock, solid rock, like granite, that you cannot only by explosive to remove it, so what you do, you install the pipe over the rock, okay? We have some cases and Moti gives some answers. We know how to do it. How install pipes up on the surface, up of a rock that you cannot dig at all. We have the other extreme, the best case scenario, everything is sand, America. And you have in the middle, you are asking about the middle. Look, digging our channels 1 meter depth it's the optimum, it's fantastic. But if you can tell us that the maximum you can get is 50 centimeters and the bedding is with sand, okay, so be it. Only in the as made, show it. Show it that for 100, 200, 500 meters, you are only the depth of 50 centimeters. And that's okay, we can live with that. If you will tell us that you are 20, 30 centimeters, this is already dangerous. Maybe we need some cover with concrete. So as you see, we don't have one answer and it depends the case. But by the book, generally speaking, we can do it. In the case we cannot do it at all, we know the solution. In the middle, please ask. We will consider the specific case and we will find the right answer. Okay?
Okay, can move on to the next question. There's a question from the Malawi team regarding the outflow pipe. From the lockable cabinet into the ground, the contractors in Malawi insist on using GI pipe because it looks neat and they don't want HDP pipe to be exposed to solar radiation. Do you have a response here?
Yeah, I am a little bit confused, but Shai will check in the drawings and we tell us, because the drainage pipe going out from the cabinet is galvanized. The only one that is coming out from the cabinet HDP is the main pipe going to the distribution.
That's
network.
what he's referring to. He's talking about the outflow pipe, I'm guessing, to the system. But in the new drawings,
you are guessing.
galvanized.
Let's say that your guess is correct, because this is not the question, but let's answer to that question.
Hi, Yaakov. Yes, I'm talking about the main pipe from the lockable cabinet to the taps.
Fantastic. I will tell you. I will tell you what are the pros and what are the cons. In the moment you install galvanized pipes into the soil, what will happen? Corrosion will start. And I saw many pipes, steel pipes, completely corroded, and it's a waste. That's why we are going down with HDP. From the other side, your contractors, yourself, myself, we are saying that we are exposed, but we are 1 meter exposed. We are 60 centimeters exposed. Please don't, you can find another solution. Put a slip, protect the HDP pipe with a slip of PVC, done, okay? So in between having the problem of the HDP pipe exposed 1 meter and having the alternative is the galvanized into the soil, I prefer to keep it HDP and to protect it with a sleeve of 4 inches PVC. Done.
Well, Yaakov, in the new plans and drawings, we actually are doing the transition to HDPE pipe in the ground, as Keith suggested, in a manhole. And you and I talked about it a little bit, me and you, Yaakov. So maybe I'm suggesting here, and tell me what you think, if we can do when the pipe enters the ground, the galvanized steel, can we put a PVC just on the part that is in the ground, and then in the manhole, it's not a problem. It can do the transition.
To put the PVC sleeve.
PVC sleeve, yes.
Yeah, you can do that. You can do that. Perfectly right. You can do that. A PVC sleeve. If we are going 2 inches galvanized, so go 4 inches PVC. Perfect. Okay? Okay, Kit?
There is one question from Roger, and Roger asked, if we don't run the EPANET analysis on the transmission network, how do I choose the right pipe diameter?
Very good. Look, as you well know, and we did it several times, and we had a presentation, the first presentation of hydraulics. If you have only one pipe going from the borehole to the tank, you don't need any software. You have rules, you have Excels. This is Isaac-Williams formula. You have one length, one diameter, you have the Q, you will see what is the head losses are. So you know, if the 50 mm is not doing it right, go for the 63. And that's it. You don't need any EPANET for one pipe that is coming from A to B. Do you agree, Roger?
I think that, but if you do want to do it in the EPANET, it's perfectly fine. We don't mind. I know that some of the Ugandan teams got freaked out a little bit yesterday when we talked about us not wanting to show the transmission line between the borehole and the water tower. It's perfectly fine if you do it. It's just not necessary for us to check it. But if you want to do it, then go ahead. If it's easier for you that way, we don't mind.
It's
and maybe try to keep it 2 separate EPANETs like we talked. One with the, one for the main line and one for the distribution.
Yes, exactly. That's what I was thinking. I can, in the same model, I can have a separate transmission network and then a separate distribution network. Otherwise, I will have to do manual calculation for me to determine the right pipe size.
As a matter of fact, because in South Africa, most of the projects are with the distribution and the main, they do 2 EPANETs. They're doing by daily base. As you suggest, this is the solution in South Africa, and this is perfectly right. But as we said, in the case you have only one tower, you can do it as you wish. If you have 2 towers, it's another thing you need to do it. Because if you are only one, as you wish. Either way, it's okay, because in the TDH calculation, in the Excel prepared by Shai, you already have it. And you have the formula there. In the moment you put the length, the Q, and the diameter, you get the head losses, you see? But as you wish.
Okay, one question here from Dio. He's asking if we can edit out all the things that we don't want the contractor to install on a particular project, because oftentimes they do bill it and then they buy things that are unnecessary for the project. And he is referring to the pressure switches and the floating mechanical valve, and we did not cover it yet. So I do want to go over to here in the pump and solar system. All of these control accessories are actually here, and Ben and Meir are going to go over it in a little while. So here, if you have a floating switch, then there's no need for the mechanical valve, because the floating switch is acting as what closes the pump. If you have 2 towers and then you install a mechanical valve in each tower, then you need to have the pressure switch as well. So those 2 come together, but we should never see all of these 3 together, either those 2 or this one. And it's your responsibility to make sure, like everything else, that the contractor put the right amounts and he didn't just like charge us extra for something that we don't need.
I should add to that, as we have in the BOQ 10 meters tower, 7 meters tower, and 3 meters tower, and there is no any case that we have the 3 towers, the same here. What is not relevant, you should know beforehand, and before you pass this very, very vast BOQ to the contractor, you check your specific case. In your specific case, you don't have 90 mm, you don't have 75 mm, you write in the quantities not applicable, or even 0. And the same regarding the 3 meters tower and the 7 meter tower, if you only have one 10 meters tower. So you should know beforehand, before you pass our template to the contractor, what the case should be. And whatever is not relevant, you put non-applicable or even 0. You see?
Yeah, so you can remove, you can put in 0 everything that you don't need when you share it with the contractor. Just make sure that it's not on the template that you share with every contractor. So every project get their own BOQ.
Right.
Another question.
On the other hand, you should also check that there are no missing items.
No, that's why, Aaron, that's why we should share a full BOQ, okay? This template should be full, and only in the particular cases we should take out. We can take out. This is and not to take out, to add non-applicable either 0, in order to keep the template as full as it could be.
A question about excavation and backfilling. Why should the contractor be charging us for excavation and backfilling when it is done by the community? I think it will be ideal for the contractor to charge for pipeline and supervision. So you want to answer that, Jacob?
Yeah, you can be very, very without any concerns, because in all the countries that the community is digging and doing the backfilling, so the price here is 0 or only a small charge to supervision, but this is exactly the case. It should be written. We have other cases in other countries like South Africa that we are paying for the digging, but where, and this is almost all of our projects, the communities are doing the bidding and the backfilling, so it's included, okay? And this is exactly the case. Is there, it could be 0, it could be no applicable. You know better than him. Before you pass the template for your project, specific one, to the contractor, you fill up with non-applicable and with 0, whatever you know it's not applicable for this project.
Okay, question from a user, which I don't know his name. What do we do in cases where pipes are meant to cross small roads or valleys, not main roads or rivers?
So go down, please, have a Shai to the
up here. This?
Yeah, 551. Supply installed steel pipe sleeve where distribution line crosses roads, river, or big galleys approved by supervising engineer. This one is given answer to your question. The same as we are protecting the galvanized pipe with a PVC sleeve in order not to be corroded. The same, when we cross a road and we have a HDP pipe that cannot stand for the loads of cars or even horses or donkeys or whatever, we put a sleeve. And this sleeve should be a steel pipe, 4 inches, 6 inches sleeve pipe.
Yeah, we are going to produce a standardized drawing for that, me and Yaron, so don't worry about that. It will be, I hope we can standardize the way we're doing it, so it will also be in the BOQ, and you can give the contractor the drawing of how to do it. Another question.
I should add here, Shai,
Sure.
that we have some water streams crossings, like in the felling KMZ, and we did with gabions. So we prefer not to cross gullies, but if we need to give specific answers and like gabions, and that's why the line is here, because it's written as approved by supervising engineer. And if the solution is by gabions, so it should be here. The price should be here.
Yes, if we want to change it to gabions, we can just change the wording here when we give it to the contractor. This is just like a very general case that we can share with all the countries, but for each specific case, we can add things if we absolutely must. In terms of hard rock, would you suggest the contractor to quote for sleeving the pipe with concrete or to drill the rock, where the design is for to cross the roads? Okay, so it's a little bit more of the same, just especially for hard rock.
It's complicated, and again, it should be case by case and very specific. And we need to know what is the hardness of the rocks and what can be done. But we had this solution in the past where the rock is very, very hard, like granite or I don't know what, and it makes no sense to dig in this kind of rock, and the length is not so far. We install the pipe in the open, and we know how to cover and how to fix the pipe. But in these cases, we need to do a specific specifications for this particular case, as Moti did in South Africa, I believe it was the case.
Okay, one last question. Do we have specifications for the galvanized pipes used at the tap stands in our new BOQ? So here we actually put it in the auxiliary structure. If you go to the, to the tap stands themselves, constructor reinforced tap water kiosk as per the design drawing set provided, including all pipes and fittings. We are not specifying exactly what should be installed there. It's a very small pipe, and we don't have that specified in our drawings yet, but we are working on doing a new version of the drawings for each country that will show exactly the specification of the pipes and all the nipples and accessories inside the tap stand and the cattle trough. But for now, this line should cover us more than enough, including all pipes and fittings. Okay, Jakob, you have anything to add, or we should move on to commissioning?
From my side, it's okay, but I like to ask, if we are going to commissioning, who will be the audience for commissioning?
Who is with us right now in the Zoom, you mean? We have engineers, all engineers, and some field officers and country directors as well.
Very well.
But Jakob, please feel comfortable speaking as you would have spoken to only water engineers. Because I know that it was supposed to be for water engineers. We are just curious and we would like to be here to listen.
Okay,
so maybe we can learn. But feel comfortable doing as you would have done
No.
water engineers.
This was my conclusion.
Okay, one last question, because I think it's an interesting one. What do we do in instances where a contractor quotes a full pipe, let's say 100 meters of HDPE, for a line that is barely 100 meters, as most suppliers don't sell half pieces?
Never mind. We buy it, we pay it, it will stay with us. We are going to use it in the future.
So you mean that we should change the quantity in the BOQ to be exactly as the EPANET, or let the contractor bill us for 100 meters?
No. Two alternatives. As a matter of fact, they are not selling less than 100 meters. So one of the two. If the contractor is working all the times with us in other projects, he can keep the extra meters and use it in another project. So we should ask to bill us for the exact quantity. If he doesn't want, I don't know, it's only working one time with us and he only apply 50 meters and he have extra 50 meters, so the 50 meters should stay with us and we will use it in the next time. So it's a matter of conversation, even it's not a negotiation. It's conversation with an understanding with the contractor. Okay? But we should respect buying by 100 meters. It's okay.
Okay, great. So let me do a new share. שרון, עכשיו רואים את המצגת או לעשות חדש? Maybe we stop the recording and start a new one.
Tamar, wake up.
Yes, please stop the recording and let's do a